Kefir and Alzheimer's disease, exploring the potential of probiotics in cognitive health. Introduction. Alzheimer's disease, AD, remains one of the most challenging neurodegenerative disorders, affecting millions worldwide and placing significant burdens on families and healthcare systems. Despite extensive research, effective treatments to halt or reverse the progression of AD are limited. However, emerging evidence suggests that dietary interventions, particularly those involving probiotics like kefir, may offer a novel approach to supporting brain health and mitigating cognitive decline. Kefir, a fermented milk beverage rich in probiotics, has garnered attention for its potential neuroprotective properties. Recent studies indicate that the beneficial bacteria in kefir could positively influence brain function by modulating gut health, a concept rooted in the gut-brain axis theory. This article delves into the current research surrounding kefir's impact on Alzheimer's disease, examining both human and animal studies, and discussing the implications for future therapeutic strategies. Understanding the gut-brain axis and its role in Alzheimer's disease. The gut-brain axis refers to the complex bidirectional communication network between the gastrointestinal tract and the central nervous system. This connection allows for the exchange of biochemical signals influencing various physiological processes, including mood, cognition, and immune responses. The gut microbiota, comprising trillions of microorganisms residing in the intestines, plays a pivotal role in this communication. In Alzheimer's disease, disruptions in the gut microbiota composition, known as dysbiosis, have been observed. Such imbalances can lead to increased systemic inflammation and may contribute to the pathogenesis of AD by promoting neuroinflammation and the accumulation of amyloid beta plaques, hallmark features of the disease. Therefore, interventions aimed at restoring a healthy gut microbiome are being explored as potential strategies to prevent or slow the progression of Alzheimer's disease. Kefir, a probiotic powerhouse. Kefir is a traditional fermented beverage produced by inoculating milk with kefir grains, which contain a symbiotic matrix of bacteria and yeasts. This fermentation process results in a drink rich in probiotics, bioactive peptides, and other nutrients. The unique composition of kefir includes lactobacillus and bifidobacterium species, beneficial bacteria known for their positive effects on gut health, yeasts, such as Saccharomyces species contributing to the probiotic profile, bioactive compounds, including peptides with antioxidant and anti-inflammatory properties. These components collectively contribute to kefir's potential health benefits, ranging from improved digestion to enhanced immune function. Notably, the probiotic content of kefir has been implicated in modulating the gut-brain axis, thereby influencing neurological health. Examining the evidence. Kefir's impact on Alzheimer's disease. Human studies. A pivotal study conducted over 90 days assessed the effects of daily kefir supplementation, 2 milliliters per kilogram of body weight, in individuals with Alzheimer's disease. The findings were promising. Cognitive function. Participants exhibited a 28% improvement in mini-mental state examination, MMSE scores indicating enhanced cognitive performance. Memory enhancement. Memory test scores improved by 66%, suggesting significant benefits in recall abilities. Biomarker modulation. Reductions in inflammatory and oxidative stress markers were observed, aligning with the hypothesis that kefir's anti-inflammatory properties may confer neuroprotection. Despite these encouraging results, the study's small sample size underscores the need for larger, more comprehensive trials to validate these findings and establish definitive conclusions. Animal studies. Research involving animal models has provided additional insights into kefir's potential mechanisms of action in Alzheimer's disease. Rodent models. Studies have demonstrated that kefir supplementation can downregulate the expression of toll-like receptor 4 TLR4, a protein implicated in neuroinflammation. This downregulation was associated with reduced brain inflammation and improved cognitive function in rodents exhibiting Alzheimer's-like symptoms. Fruit fly models. Experiments with Drosophila melanogaster models of Alzheimer's disease revealed that kefir metabolites could reduce amyloid beta accumulation and enhance motor functions, suggesting a protective effect against neurodegenerative processes. These preclinical findings support the notion that kefir's probiotic components may exert beneficial effects on brain health through modulation of the gut-brain axis and inflammatory pathways. Potential mechanisms: how kefir may influence cognitive health. The proposed mechanisms by which kefir may impact Alzheimer's disease include modulation of gut microbiota. By enhancing the diversity and balance of gut bacteria, kefir may reduce systemic inflammation, a known contributor to neurodegeneration. Reduction of oxidative stress. Kefir's bioactive compounds possess antioxidant properties that can neutralize free radicals, thereby protecting neurons from oxidative damage. Enhancement of insulin signaling. Dysregulation of insulin pathways has been linked to cognitive impairment. Kefir may improve insulin sensitivity, supporting neuronal survival and function. Strengthening of the gut barrier. By promoting gut integrity, kefir may prevent the translocation of pro-inflammatory molecules into the bloodstream, reducing neuroinflammatory responses. Considerations and future directions. While the current evidence highlights kefir's potential as a complementary approach to supporting cognitive health in Alzheimer's disease, several considerations must be addressed. Limited human data. The scarcity of large-scale human studies necessitates caution in extrapolating findings from animal models to clinical practice. Variability in kefir composition. Differences in fermentation processes and microbial strains can result in variability in kefir's probiotic content, potentially influencing its efficacy. Dietary integration. Incorporating kefir into the diet should be considered as part of a holistic approach to health, including balanced nutrition, physical activity, and medical management. Future research should focus on conducting rigorous clinical trials to elucidate the efficacy, optimal dosage, and safety profile of kefir in individuals with Alzheimer's disease. Additionally, exploring the synergistic effects of kefir with other dietary and lifestyle interventions may provide a comprehensive strategy for cognitive health maintenance. Conclusion. The exploration of kefir as a potential adjunctive therapy for Alzheimer's disease offers an intriguing avenue in the quest for effective interventions against cognitive decline. By leveraging the gut-brain axis, kefir's probiotic properties may confer neuroprotective benefits, as suggested by preliminary human and animal studies. However, the current body of evidence is in its nascent stages, and further research is imperative to substantiate these findings and translate them into clinical recommendations. In the interim, individuals interested in incorporating kefir into their diets should do so as part of a balanced and healthful lifestyle, recognizing that while promising, kefir is not a panacea for Alzheimer's disease. Collaborative efforts between researchers, clinicians, and nutritionists will be essential in unraveling the complexities of diet-based interventions in neurodegenerative diseases.